Alright, this example says the gravitational force between two people is F when separated by a distance of D. If that distance is quadrupled, what will the gravitational force be? So you have person A, you have person B, they are separated by a distance of D, and they have a gravitational force of F. So if you were to quadruple that distance such that these people are much further away, you want to know what impact that has on the force. Now you should realize right away that when you get further away, the gravitational force is going to decrease. But the question is by how much? And that's where Newton's law of universal gravitation comes into play. We would say F equals G m1 m2 over d squared. So at this point, you want to say, okay, well, what impact is the distance going to have? And a lot of people get confused. They don't know what to do with the masses and so forth. But if you look, the mass of the people is going to be the same in each case. So what I'm going to do is I'm actually going to cross that out. And that's gone. And basically what that leaves me with is the proportionality where F is really proportional to d 1 over d squared. So if I have 1 over d, like I did here, that gave me a value of F. So what I'm going to do is now, instead of plugging in D here, I'm going to plug in 4D. And when I do that, you get F is proportional, and then we do 1 over 4D, and then that whole thing is squared. And that's the key thing here, is this is an inverse square relation. So when you do this, you actually end up getting 1 over 16D squared. Well, remember, when we had 1 over d squared, we got F. So I have 1 over d squared here. The difference is I have F, and then I have over 16. So if I quadruple the distance, the gravitational force actually reduces to 1/16 as much, because it's an inverse square law. If I were to double the distance, the gravitational force would go down by 4, and so forth. You always have to square that number when it deals with distance.